Good evening, students. Welcome to the chemistry class. We are learning the third chapter, Reactivity series and Electrochemistry. In the first part of the video, we discussed about the reactivity of different metals with water, air, and acids. And also we learned the metals can be arranged in the decreasing order of their reactivity. And that series is called the reactivity series. Using this series, we can compare the reactivity of different metals. The metals above the hydrogen can displace hydrogen from dilute acids, whereas below the hydrogen cannot displace. So let's learn more about this displacement reactions using reactivity series. So let's start. Prepare some copper sulfate solution in a boiling tube and dip a zinc rod in it. Let's observe the changes after some time. In copper sulfate, positively charged copper ions and negatively charged sulfate ions are present. The zinc is more reactive than copper. Hence, zinc donates 2 electrons and goes to solution as Zn2+ ions. These ions react with negatively charged sulfate ion and forms zinc sulfate. The blue color of the copper sulfate solution is due to the presence of copper ions. The copper ion reaches the zinc rod and accepts 2 electrons and become copper atom. As a result, copper gets deposited on the zinc rod and the color of copper sulfate solution decreases gradually. The chemical reaction taking place here is given. Zn plus CuSO4 gives ZnSO4 plus Cu. Here, the metal that gets displaced here is copper because zinc is more reactive than copper. Metals having high reactivity displace the metals having less reactivity from their salt solution. Such chemical reactions are known as displacement reactions. The metals with higher reactivity gets oxidized and those with lesser reactivity get reduced. So displacement reactions are also known as redox reactions. Let's get familiarized about some redox reactions. Let's rewrite the above equation showing the nature of ions as below. As you have learned in the 9th standard regarding the oxidation number of elements and compounds, you know the oxidation number of an atom existing in an elemental state is considered as 0. So here, the oxidation state of zinc is 0. In copper sulfate, copper exists as +2 and that of sulfate is -2. In ZnSO4, zinc exists as +2 ion and sulfate exists as -2 ion and the charge of copper atom is 0. Now analyze the change happened in the oxidation number. Zn 0 changes to +2, that is increase in oxidation number. The process of increase in oxidation number is called oxidation. So we can write the equation Zn gives Zn +2. 0 changes to +2. Zn +2 plus 2 electron. Zinc loses 2 electron. And this equation is called oxidation reaction. Similarly, copper exists as Cu2+ and it changes to 0. That means decrease in oxidation number. So rewrite the equation as Cu +2 plus 2 electron gives Cu. Copper accepts 2 electron donated by the zinc, So this reaction is called reduction reaction. In the same reaction, both oxidation and reduction takes place simultaneously. So such reactions are called redox reactions. Don't you remember the redox reactions that we learnt in the 9th standard? So here, the redox reaction can be written as Zn plus Cu plus 2 gives Zn plus 2 plus Cu. While writing redox reaction, omit the number of electrons donated or accepted by these atoms. Consider another example of a copper rod dipped in silver nitrate solution. Let's write the ionic nature of this equation first. In this equation, the atoms copper and silver exist in elemental state. So, their oxidation numbers will be equal to 0. We know the oxidation number of nitrate as -1. So, it is easy to find out the oxidation number of silver and copper from silver nitrate and copper nitrate respectively. The oxidation number of silver is +1 and that of copper is 0. In copper nitrate, the oxidation number of nitrate is -1. Since 2 nitrate ions are there, so the charge of copper becomes +2. The oxidation number of silver is 0. Analyze the changes happen to silver and a copper atom. Silver, the number +1 changes to 0. That means the oxidation number decreases. So we can write the equation as 2Ag plus 1 plus 2 electron gives 2Ag. Silver ion accepts 2 electron donated by the copper atom. So this equation is a reduction reaction. And for copper, the number 0 changes to +2. So it shows an increase in oxidation state. Hence we can write Cu gives Cu plus 2 plus 2 electron. Copper donate 2 electron to become copper ions. So it is an oxidation reaction. In this equation, both oxidation and reduction takes place simultaneously. So we can say displacement reactions are also known as redox reactions. Now let's write the equation for redox reaction. So let's write the reactant first in the first equation. 2Ag plus 1 plus copper gives product 2Ag plus Cu plus 2. Is that clear for you? So let's summarize today's portions. In the beginning, we learnt about displacement reactions. The metals having high reactivity displace the metals having less reactivity from their salt solution. In displacement reactions, the metals with higher reactivity get oxidized and those with lesser reactivity get reduced. In displacement reaction, both oxidation and reduction takes place simultaneously. Hence, they are said to be redox reactions. Thank you.